Hello, I am Abdullah Abdali Jassen, Senior Engineer in Computer Center, University of Baghdad, and on behalf of Mr. Saifuddin Abdul Amir Muhammad, Faculty Member in College of Engineering, University of Baghdad, we are very pleased to participate in this video presentation about our new initiative, Watson for Enterprise Firmware and Hardware Management, in the virtual conference of Enterprise Computing Conference. Abstract. Cognitive computing and deep learning are essential in modern and futuristic enterprise solutions. These solutions are either cloud computing or cloud, fog, and edge computing, which need efficient management for software, firmware, and hardware resources. The main goal of our research is starting a new initiative for applying the deep autonomic intelligence in firmware and hardware management, because till now, most projects treat the firmware and hardware as static pieces and putting all dynamic changes in the software levels. Therefore, most of cybersecurity actions are efficient in the software level, but vulnerable in the firmware and hardware levels, which causes the enterprise resources bleeding and threatening the enterprise entity itself. IBM Watson enters almost all fields, which will push this initiative ahead to generalize the solution as cloud service or on-premise solution for complete dynamic multi-layer cybersecurity. Please note, in the other slides of this presentation, every Watson is IBM Watson. Why Watson for enterprise firmware and hardware management? Today's enterprise computing is based on the traditional enterprise architecture, and it is not cost-effective, very complicated, needs training for each part, needs experiences, needs updating, needs time to develop its functions, difficult to manage, difficult to configure, difficult to maintain. Also, we can see many enterprises have security problems from time to time. 2. The enterprises need huge investment in cybersecurity, and the return of investment should be ensured exactly. 3. Computers manufacturers don't give approval to share the source code of their customized BIOS. Therefore, we suggested the cognitive cybersecurity terminal. 4. To solve the above problems, we suggest the cognitive dynamic software-defined cybersecurity, which is based on Watson middleware, firmware, and hardware using open source technologies. 5. Our solution is based on the cognitive dynamic software-defined enterprise. The goals. 1. Redesigning the enterprise cybersecurity. In this initiative, we suggest the following novel ideas. A. Watson for firmware and hardware management cloud services. B. On-premise enterprise proxy server for local firmware and hardware management. C. Cognitive cybersecurity terminals for enterprise computers and mobile devices. 2. Automating the real-time firmware and hardware management, quality assurance, optimization, design, implementation, and operation of ICT infrastructure. 3. Preventing the systems from the spyware, viruses, and other attacks by analyzing the behavior of the firmware and hardware resources when it is accessed by the software. 4. Unifying the efforts of the firmware and hardware developers, universities, companies, organizations, communities, individuals, for new cost-effective, reliable, and easy maintenance cybersecurity solutions. 5. Pushing the open source technologies to a new level of customization depending on the artificial intelligence. Preparations and requirements. 1. Main fully supported open source technologies and projects. A. Open source corpus. B. Open source real-time operating systems for embedded systems, Linux or non-Linux RTOS. C. Well-known open source Linux, Ubuntu, CentOS, etc. D. Apache Kafka, Apache Spark, Hadoop, SQLite, and MongoDB. E. GNU Compiler Collection, GCC, LLVM, and OpenMPI. F. FPGA open source development tools like Chisel language and Spinel HDL language. G. Open source IBM Power Instruction Set Architecture, Libre RISC-V and RISC-V. H. NVIDIA Deep Learning Accelerator NVDLA. 2. Fully supported technologies for ARM architecture, including FPGA hard cores and system on a chip from other companies. 3. Partially supported Intel x86, x64, Intel Triana Core UEFI development kit. 4. DevOps automation, including continuous integration and continuous delivery, CI/CD. 5. The supported technologies layers are organized as in Figure 1. Project implementation. The main project is divided into 3 sub-projects, which will be carried out in parallel as follows. Sub-project 1, implementing Watson for firmware and hardware management. Sub-project 2, feeding descriptive information and artificial intelligence algorithms with data. Sub-project 3, implementing the cognitive infrastructure. Sub-project 1, implementing Watson for firmware and hardware management. Step 1, implementing the cognitive DevOps. Step 2, implementing Watson for firmware and hardware management cloud services. Step 1, implementing Watson DevOps CI/CD Manager. 1. We can use the following DevOps automation servers and continuous integration, continuous delivery tools. A. Ansible. B. Jenkins. C. Travis. 2. Watson for firmware and hardware management should be integrated with the above-mentioned CI/CD DevOps automation servers and tools to do the following. A. The generative adversarial networks generate the firmware and hardware code. B. Continuous integration, continuous delivery tools will integrate and deliver the code to the target systems. C. Auto-feeding the code patterns libraries to the Cognitive Experience Bank, which is managed by the WFHM under the System Developer Supervision. D. Auto-debugging code by using CI/CD to the target system. E. All CI/CD operational information like time, date, location, unit ID, code ID, hardware ID are registered in the dedicated distributed ledgers stored in distributed SQLite database DQLite for firmware and hardware behavior checking and predict the operational problems of CI/CD of WFHM. F. Auto self-assessment, key performance indicators, performance appraisal, quality assurance. Step 2. Implementing Watson for firmware and hardware management cloud services. 1. Experiences Bank for hardware and firmware design, configuration, debugging, and programming patterns. 2. Operational knowledge base for operational analysis, predictions, ledgers, configurations, and debugging. 3. Machine learning include deep learning, training, inferencing, and generative adversarial network. 4. Relationships and connections manager. 5. Distributed ledger management, looks like blockchain. 6. Watson integration with Eclipse IDE and Unified Modeling Language UML. Subproject 2. Feeding descriptive information and artificial intelligence algorithms with data. Step 1. Feeding descriptive information to Watson. Step 2. Feeding the firmware and hardware algorithms to Watson. Step 3. Feeding the cognitive middleware algorithms to Watson. Step 1. Feeding descriptive information and data to Watson. 1. Hardware descriptive information and data including A. An instruction set architecture mapping for 1. Register machines x86, x64, ARM, RISC-V, Power, Little Endian, and other architectures. 2. Artificial intelligence accelerating hardware units, GPU, TPU, etc. 3. Stack machines, Java, optimized processor, fourth language stack processors, and others. B. Instruction and register field settings, data registers, address register. 4. 1. Memory management unit descriptors, descriptor tables and hardware, paging hardware, segmentation hardware, translation loci buffer hardware, and task switching registers field settings and its description. 2. Floating point hardware instructions or emulated instructions, branch processing instructions, cache unit instructions, debugging instructions, and input-output instructions. 2. Memory and input-output mapping for computer or system on a chip. 3. Input-output device driver information, register field settings, data registers, interrupts, etc. 4. Encryption, decryption hardware information, registers field settings, and instructions. Step 2. Feeding the firmware and hardware algorithms to Watson. We will use the intermediate language bytecode to write the following. 1. Cognitive CPU, MMU, FPU, GPU, TPU management algorithms and descriptions for firmware, hardware, and debugging. 2. Cognitive security management terminal algorithms for authentication, authorization, encryption and decryption, and self-debugging. 3. Cognitive network description and management algorithms for network hardware, network firmware, and network protocols debugging. 4. Cognitive input-output devices descriptive information and management algorithms, I/O devices firmware and hardware management algorithms, and debugging algorithms. Note: for encryption and decryption, we suggest the dynamic password generation using random pseudo-noise compact with random mapping transform algorithm. Step 3. Feeding the cognitive middleware algorithms to Watson. These algorithms are specifically to the firmware, hardware, networking, task management, and transaction management for 1. Self-assembling, self-organizing, self-configuring, self-operation capabilities, self-predictive failure, and self-maintenance, diagnosing and repairing. 2. Self-interconnection, software-defined infrastructure, software-defined network, and software-defined radio. 3. Self-optimization, self-governance, self-assessment, and quality assurance. 4. Integration with other artificial intelligence systems, hardware, and software. 5. Experiences, information, and data exchange connection. We have a research proposal, high-speed massive MIMO. We will integrate with our project in the future. Sub-project 3. Implementing cognitive infrastructure. Step 1. Implementing Watson Cloud resources. Step 2. Implementing enterprise on-premise secure firmware hardware management proxy server. Step 3. Implementing cognitive security terminal. Step 4. Implementing internal cognitive firmware and hardware management unit. Step 1. Designing and implementing Watson Cloud resources. 1. Designing and deploying customized cloud services based on IBM Fabric for deep learning, which is based on the deep learning tools and framework with Deep Learning Accelerator. 2. Designing and deploying customized cloud services based on IBM Watson Internet of Things, integrating these services with enterprise firmware and hardware management proxy servers. 3. Designing and deploying IBM software-defined network cloud services. 4. Deploying the IBM DevOps cloud services. 5. Integrating these services with enterprise firmware and hardware management proxy servers. Step 2. Implementing enterprise on-premise secure firmware and hardware management proxy server. 1. Implementing the enterprise network between Watson firmware and hardware cloud services and the cognitive security firmware terminals. 2. Implementing the operation management center for autonomic network, including configurations, operations, and debugging of network firmware. 3. Implementing the local real-time GPU deep learning accelerator server for analyzing the firmware and hardware behavior and failure prediction. B. Managing the operational data analysis, classification, and testing. C. Managing bank of code patterns or snippets and debugging procedures. D. Local code patterns generation for applications firmware, hardware design, debugging code. Step 3. Implementing the Cognitive Cybersecurity Terminal, CCT. 1. Choosing the suitable single-board computer, SBC, open source design and firmware to implement the CCT as follows. A. CCT I/O devices, compact keyboard plus 3.5-inch or more display. B. CCT connections. 1. USB connection between CCT and target system. 2. Ethernet connection between CCT and enterprise proxy server for firmware and hardware management. 3. iSIM or eSIM card for mobile connectivity, IoT for mobile secure data transfer. C. Secure tracking system uses GPS plus GLONASS plus BIDO. D. 9-axis sensors, 3-axis accelerometer, 3-axis gyro plus 3-axis magnetic sensors. E. System on a chip plus memory. The CPU may be open source or closed source. 2. Programming and activating the following functions. A. Traditional functions. 1. Face recognition and fingerprint detection for secure authentication. 2. Accessing the computer firmware debugging and checkpoints. 3. Manually controlled secret keys by alphanumeric code. B. Cognitive functions. 1. The CCT can access the Watson firmware and hardware services either directly or via the enterprise proxy server. 2. CCT can verify the firmware and hardware applications to find, quarantine, and remove the vulnerability, spyware, viruses, dangerous software, and firmware routines or functions. 3. Protecting the user data and privacy. Step 4. Implementing the internal cognitive firmware and hardware management unit, ICF-HMU. 1. Choosing the suitable open source computer mainboard with the ability to access and program the firmware of the dedicated CPU core or system on a chip inside the computer. 2. Implementing the device driver functions for tightly coupled connection between ICF-HMU and CCT cognitive functions. 3. Implementing the firmware level cybersecurity monitoring embedded systems. Note: the idea of firmware and hardware management is not new. Some well-known companies have management engine, Intel Management Engine, or Security Processing Unit for Qualcomm, or Secure Processing Unit. Suggestions and opinions. 1. Establishing an internet community for cognitive, dynamic, software-defined enterprise cybersecurity. For feeding the required information and algorithms to Watson. 2. Discussing the ability for dedicated cognitive cybersecurity hardware unit in computer systems or devices. 3. Encouraging the coordination with other communities, universities, and companies who are mentioned in this presentation. Also, establishing a GitHub for all project stages and for the required open source technologies from them and customize it by making the plugins or functions libraries to enable Watson access it efficiently. 4. We can cooperate with other universities or companies in design and implementation of the complete integrated cognitive firmware and hardware management. Please note, firmware and hardware management cannot be separated from the cybersecurity. We don't reinvent the wheel. We use open source tools and putting the steps to use it with IBM Watson. Please send your questions to abdullah@uob.edu.iq or saifuddin@uob.edu.iq. Thank you all and be safe.